Go look at these examples here.
Okay, it is necessary.
Okay, so some of these are a bit thought-provoking, but just rest assured that when you get to the quiz, then probably won't be that difficult. But the harder the problems that you do in preparation for the quiz, the better off you're going to be during the quiz. Okay? All right. So, all right, gentlemen back there, let's do a better job with our masks. All right. So, let's take a look here. All right, firstly, I don't know, Mr. Tidwell, we got an object lying motionless. What forces are going to be going on there? Okay, now, remember on planet Earth, so you're always going to have mean old Mr. Gravity going down. What else?
I have a question.
Yes.
So, for the gravity, we don't need to write the whole thing out? For like F grav?
You could write something like that. I mean, as long as you make it clear what's what, then it's fine. I don't think that there's any other thing that starts with G. What? Yes. Okay. All right. So, then what else? Right. Now remember, if you have gravity working by itself, then that thing means the thing is falling. Right? So, and that's just true in general. That's what equilibrium means, is when the forces are balanced. If they're not balanced, then you're going to have movement, a change in movement. All right? Okay. So, number 2 then. Okay, Daniel, what do you have here?
Application going to the right.
Okay, this is the application force.
And then, normal going the opposite direction?
Yeah.
No.
Yeah, Matthew? What?
Is it friction the other way?
Now, it would be, but what does it say in the problem? Okay? So, shh. Everyone stay focused here. So, there's no friction, so you're not going to have the force going to the left. All right, there's no force going to the left. In other words, that application force is unopposed, so that body's going to be moving to your right for sure, but there's going to be 2 other forces involved here. Yes?
Gravity going down and then the normal
Right.
going up.
Just like that. All right. So then clearly, if you look at that, you see the imbalance going to the right, so the object will be moving to the right. If somebody asks you that question. All right. Now we're going to have the same issue, only a little bit different. Okay, Mr. Hensley. Now what are we going to do?
Application to the right.
Mm-hmm.
And then friction to the left.
Good. Okay. And what other forces?
Oh, gravity down.
Good.
Normal.
All right. Remember, and this is important enough that we're going to write it off to the side here, friction always opposes movement. Okay. So if there's nothing trying to move, then there's no friction. But if it's trying to move, then whatever is rubbing against it, that's going to cause a friction, and it's going to try to stop that movement, basically. All right. Okay. All right, Jack.
So there's gravity pulling down,
Sure.
and then there's the application force points up.
Now, that's one way to think of it, but more specifically, what did you call it, Maya? Tension. All right. That's the tension. And so anytime there's a rope or a chain or a string or whatever holding something else, that's tension in that line. All right, that force is what tenses up the line. That's why it tightens, etc. That's like the perfect example of like these outlets you see hanging around the room. Right? Because without that tension from the cord, those boxes would fall down. All right. And there's nothing moving left or right, nothing pushing it left or right, so we don't have to put anything in there left or right. All right, slides at a constant speed across the surface without friction, okay? There's two little things in there that they threw in that make sure that will affect our diagrams. Okay? So, what two forces do we know we're going to put here? Good, gravity and the normal force. Okay. Any other arrows? Now, that's a good thought, but why do we know that there's not an application force? What on there tells us there's not an application force? Constant speed. Okay, if something is moving at a constant speed, that means it's not being changed. It's not being changed in terms of its movement. So on planet Earth, if there was no friction, then if I started an object moving down a hall, it would just keep moving until something stopped it. Right? Because of friction on the floor, whatever it's moving across, it does eventually stop here because something does oppose the movement. But without that friction, it would just keep going, right? Now, there's no way that we can make a system without friction on planet Earth because there's always going to be some rubbing between the two objects, right? That's why some things you'll have like travel across air because there's less friction in air, so there's less opposing that movement. But eventually, that's what would happen, right? And that goes into that Newton law. You guys have probably heard of object in motion tend to stay in motion. They tend to stay in motion because there's nothing to stop them. Yeah. All right. Okay. Now, and because there's no friction, there's nothing that would oppose the movement. So, all right. Okay, so an object slows down while moving across the surface due to friction. All right, so what are we going to put in here for sure? Since we're on planet Earth. Good. And opposing that will be the normal force. We know that it's opposing it because it's not moving up or down. And it says the object slows down surface due to friction. So which way is our friction going to go? To the left, right? Because the object is moving to the right, so it opposes the force. That's our force of friction. All right. Okay. No. How do we know that there's no application force? Anybody? Yeah. Constant speed, or it is slowing down. Okay, it's slowing down due to the friction, so there's nothing pushing it the other way. If there was, then presumably it would overcome that friction. But right. Slowing down means that the friction is winning the battle. Okay. All right, now this one you have to think about a little bit. Okay. We're still on planet Earth, so what do we know? Now, be very careful here because gravity always works perpendicular to the surface of the Earth. Surface of the Earth is down here, right? So, our gravity, therefore, is going to work like this. right? So it's not working perpendicular on that box necessarily, but it is still working perpendicular to the earth. Now, that means that the normal is 100% or 180 degrees opposed to the gravity. It's going to go here. Right? Now, the result of, let me make my surface of the earth better. The result of the gravity does mean that the object keeps moving down that box or down that ramp. But it's not going to move as fast as it would if it was just dropped off, right? It's going to be slower because it's not exactly the same amount. Now, just a preview of coming attractions here, everybody. If you take this force right here, boom, what do you make right there? Do you see it? Yay.
Triangle.
Triangle. So then when you take physics, what you can do is use some geometry, some tangent, cosine, Pythagoras theorem to figure out with that triangle what the forces are that are involved. Yes.
Yay.
Be a good time. Unfortunately, we can't do this class because you guys, not everybody has the same math background. I know it's sad, but in your future, you take physics, that's what you'll do. Use lots of that geometry. Okay? I know, it's disappointing. But, that's the way it goes, I guess. So, all right. Now, it says frictionless, so there's no force going to the left. That's it. There's nothing else to put on there. All right. Questions on that? All right. Here we go. Next one. You have held motionless by a rope on an incline. So again, you got your gravity. You got it perpendicular to the surface of the earth, like this. You have the normal force like this. All right. Now, what else are you going to have? Yeah.
Tension.
Good. You have tension this way. And just put F of T. And that's what's going to equal out gravity. All right. And again, the tension on that is less than what it would be if it was just hanging from the ceiling or something with the same object. Because you can see how it's changed in its angle, so it's not going to get the full effect of gravity. All right. Okay. So, what do we need to put in this in number 9? Good. Okay. You got gravity, you got the normal force. Now, we have to come up with something here, right? Because it's stopping it from going down the ramp. What? Would be friction, right? You'd have a bit of friction going this way, which would oppose that motion. Okay? Got it? All right, good. Okay? Now, what about this one? Mm-hmm. And that's it, because there's no friction, right? Or no, I'm sorry. You'd have to have some friction this way to make that at a constant speed. Otherwise, it would accelerate down. But things accelerate down hills. Right? So if it's slowly going down the hill, that's why. It's because there has to be some friction between it and the ground. All right, any questions on that? All right, so start to work on the speed problems probably in the next day, but probably tomorrow sometime. I'll go ahead and post the key to those problems to make sure, so you can check them to make sure that you're doing them right. But I would try to do most all, if not all of them first. All right, let's make yourself get that good practice in. When you take the test,